in this video, we are going to discuss about Dalton's law. Dalton's law of partial pressures from gaseous state. So what is Dalton's law? Here, when two or more non-reacting gases are taken. So here, for example, let us take a container at a constant temperature and volume. And in this I have taken three gases, and the gases are non-reactive gases A, B, C. Now total pressure exerted by these gas molecules. So let us take it is PT, means P total. So total pressure exerted by these gas molecules is equal to the individual pressures of gas molecule A, gas molecule B and the gas molecule C. Are you getting my point? Here, the total pressure exerted by these gas molecules is equal to the individual pressures, means partial pressures of this A, means PA, partial pressure of gas A, plus partial pressure of gas B, plus partial pressure of gas C. This is Dalton's law. When two or more non-reacting gases are taken into a container at a constant temperature and a volume, here the total pressure exerted by the gas molecules is equal to the partial pressures of the each gas. Partial pressures of each gas. So here what is Dalton's law? It is the total pressure exerted by the non-reacting gas molecules is equal to the partial pressures or the individual pressures of the gas molecules. That is Dalton's law of partial pressures. So by applying ideal gas equation, first let us take it here, it is P, here P total, V, here V is constant, PV is equal to, here how many moles are there, how many number of moles are there, and PV is equal to nRT, no, ideal gas equation. So N1 it is the moles of A, and here N2 it is the number of moles of B, gas B, and N3 it is the number of moles of gas C. So where N1, N2, N3 are the moles of gas A, B, C respectively, and R universal gas constant and T is also constant. Let us take this is equation number 1. Partial pressure of gas A, V is equal to, it is N1 RT. This is equation number 2. Now partial pressure of B, V is equal to N2 RT. This is equation number 3. And the partial pressure of gas molecule C is equal to N3 RT. This is equation number 4. Now here I have applied ideal gas equation. So it is total pressure I have taken. So total pressure, it is nothing but number of moles of gases A, B, C, and partial pressure of gas A is equal to, because as per the according to Dalton's law, total pressure exerted by the gas molecules is equal to partial pressures of number of how many gas molecules are there, that depends upon that number. So here three gases I have taken. Here PA, PB, PC are the partial pressures of gas A, B, C respectively, and N1, N2, N3 are the number of moles of A, B, C gases respectively. So these are the 4 equations. Okay. Now E2 divided by equation 2 divided by 1. Now write down PA by P total. Instead of P total, here I am writing PT, which is equal to N1 by N1 plus N2 plus N3. So RT, V and V, they get cancelled. PA by P total is equal to N1 by N1 plus N2 plus N3. So what is this? Number of moles of one component by total number of moles. number of moles of one component by total number of moles, which is nothing but mole fraction, chi. What is mole fraction? Here, number of moles of one component to the total number of moles. So, for example, number of moles N2 by N1 plus N2 plus N3. Number of moles of one component divided by total number of moles. So, this is equal to chi 2. Okay, which is nothing but mole fraction. Now, I am replacing this with chi 1. So, it is partial pressure of A divided by total pressure, which is equal to chi 1. Now, PA is equal to PT, total pressure, into chi 1. This is the formula for the partial pressure of gas molecule A. So, partial pressure. So, here I have taken 3 non-reacting gases and I have written ideal gas equation for the total pressure. So, total pressure means total number of moles. So, N1, N2, N3 are the number of moles of gas A, B, C respectively. And here PA, PB and PC. Here I have written ideal gas equation for the 3 non-reacting gases, and here partial pressure of gas A, partial pressure of gas B, partial pressure of gas C. Why we are writing all this? Because as per Dalton's law, total pressure PT is equal to total pressure exerted by the non-reacting gas molecules is equal to partial pressures of the individual gas molecules. This is at a constant temperature and volume. This is Dalton's law. So here, how to calculate, how to find out the partial pressure? The partial pressure of the gas A is equal to total pressure into mole fraction. Now you divide this third equation by 1. 3 divided by 1. 3 divided by 1. What you will get? Here PB by P total. PB by P total, which is equal to N2 by N1 plus N2 plus N3. So, which is equal to, this is chi 2, as I told you already. So, here partial pressure of gas B is equal to, partial pressure of gas B is equal to, now partial pressure of gas B, PB is equal to PT into chi 2. Find out partial pressure of gas C. Divide 4 divided by 1. So here it is, what we will get? PC, partial pressure of gas C, which is equal to P total is equal to N3 by N1 plus N2 plus N3, which is equal to chi 3. So PC is equal to partial pressure of gas C is equal to, here, total pressure into mole fraction. Clear? So this is the formula you have to remember. Partial pressure is equal to total pressure into mole fraction, and the total pressure is equal to partial pressures of individual gas molecules. This is Dalton's law. Okay. Now here, what is mole fraction? Chi 1. Here I told you, mole fraction is equal to number of moles of one component to the total number of moles. So how to calculate number of moles? What is the formula for the calculation of number of moles? Number of moles N is equal to weight by molecular weight. This is the formula to calculate number of moles. This is also you have to remember. Weight by molecular weight. If it is a molecule, weight by molecular weight, that gives you number of moles. Okay, so what is the formula for the calculation of partial pressures? Partial pressures is equal to total pressure into mole fraction. What is mole fraction? Here, number of moles of one component to the total number of moles. How to calculate number of moles? Here, number of moles is equal to weight by molecular weight of that particular component. Okay. Now let us solve one problem so that this topic will be more clear to you. And here these are the formulas you have to remember. B, C and so on. Now partial pressures is equal to total pressure into mole fraction. So mole fraction, which is chi 1, mole fraction is N1 by N1 plus N2 plus N3. And how to calculate the number of moles? Weight by molecular weight. This is the formula for the calculation of number of moles. Now look at this problem. Here a gaseous mixture of 2 moles of A, 3 moles of B and 5 moles of C, 10 moles of D contained in a vessel. Assuming that gases are ideal and partial pressure of C is 1.5 atm, the total pressure is. And the options are, these are the 4 options. Now, what is the data given? It is 2 moles of gas A. So, number of moles of A is equal to 2. And 3 moles of gas B, number of moles of gas B is equal to 3. And 5 moles of gas C, number of moles of gas C is equal to 5. And 10 moles of gas D, number of moles of D is equal to 10 moles. Contained in a vessel, assuming that the gases are ideal and the partial pressure, here another point, the partial pressure of C means the partial pressure of C is equal to 1.5 atm. This is the data given and they are asking you to find out the total pressure. Now what is the formula for the calculation of total pressure? Here the partial pressure is equal to total pressure into mole fraction of A. Okay. Now what is mole fraction? What is the formula for the calculation of mole fraction? Mole fraction of A is equal to number of moles of A by number of moles of A plus number of moles of B plus number of moles of C. Here no need to find out number of moles. If they are given in grams, you have to find out the number of moles too. But here they have already given number of moles. So here no need to calculate the number of moles. Now first calculate this chi A. Here another one is given. Here the partial pressure of C is given. Now let us assume it is C and it is C. Now it is number of moles of C by total number of moles. What is the number of moles of C? It is 5. 5 divided by total number of moles. 2 plus which is equal to 2 plus 3 plus 5 plus 10. Okay, which is equal to 5 divided by 20, which is equal to 1 by 4. What is chi A? It is 1 by 4. Which is 1 by 4. Now here, what is partial pressure? It is PC, which is given 1.5, which is equal to, they are asking you to find out the total pressure. Now PT into 1 by 4. Now, what is PT? PT is equal to 1 by 5 divided by 1.5 divided by 1 by 4, which is equal to 1.5 into 4, which is equal to 6 atm. So your option is C. Clear? So here number of moles are given. They are asking you to find out the total pressure. So we know when the partial pressures are given, the formula is partial pressure is equal to total pressure into mole fraction. Here partial pressure of C is given, mole fraction of C I have written. So what is mole fraction of C? Here it is mole fraction of C, number of moles of C by, here what is mole fraction? Total number of moles of that particular component divided by total number of moles. So number of moles of C divided by total number of moles. So just simple substitution. Okay. Now let us solve another problem so that this topic will be more clear to you. Now the problem is the total pressure of the gaseous mixture of 2.8 grams of nitrogen. So I told you no, here weight is given. So 2.8 grams of nitrogen, it is weight of nitrogen, and 3.2 grams of oxygen, 3.2 grams of oxygen, it is weight of oxygen, and 0.5 grams of hydrogen, it is weight of hydrogen. Now, and the total pressure is 4.5 atm. So PT is equal to 4.5 atm. Now he is asking you to find out the partial pressure of each gas. Partial pressure, PP I have written, which is partial pressure. Okay, now you have to calculate what is the formula. First you have to write the formula for the calculation of partial pressure. So partial pressure of any component is equal to, for example, let us take it is partial pressure of A, which is equal to total pressure into mole fraction of A. Okay, so now first for this, here he has given total pressure he has given. Now he is asking you to find out the partial pressure of each individual gas, and mole fraction also you have to calculate because here weight is given. Now calculate number of moles. Number of moles is equal to weight by molecular weight. So here number of moles of nitrogen, which is equal to, here number of moles is equal to weight, which is 2.8 by molecular weight. What is the formula for the calculation of number of moles? I told you number of moles N is equal to weight by molecular weight. So what is weight of nitrogen? So it is 2.8 and the molecular weight is 28. So 28. So which is equal to 0.1 mole. And the number of moles of oxygen, which is equal to 3.2 weight by molecular weight, 2 16s. 2 into 16 oxygen molecule, no? So 2 into 16, which is 32, which is equal to 0.1 mole. And next, number of moles of hydrogen, which is equal to weight 0.5 divided by 2. So which is equal to 0.25. So these are the number of moles. Now you have to find out total number of moles, because for the calculation of what is the formula for mole fraction? Mole fraction of A, for example, you are calculating number of moles of A by number of moles of A plus number of moles of B, means number of moles of C. Okay, so total number of moles is equal to total moles is equal to number of moles of nitrogen plus number of moles of oxygen plus number of moles of hydrogen, which is equal to 0.1 plus 0.1 plus 0.25, which is equal to 0.1, 0.1, 0.2, which is equal to 0.45. 0.45, no? Yeah, 0.45. Now, these are total number of moles. Now, the partial pressure, he is asking you to find out the partial pressure of, first one, partial pressure of nitrogen, which is equal to total pressure into mole fraction of nitrogen. Mole fraction of nitrogen means number of moles of nitrogen divided by total number of moles. So what is the partial pressure of nitrogen, that you have to find out. So total pressure is equal to 4.5 into mole fraction of nitrogen is nothing but number of moles of nitrogen by total number of moles. What are total number of moles? 0.45. Now, what is the mole fraction of nitrogen? Number of moles of nitrogen by total number of moles. Total number of moles is 0.45. So, 4.5 into mole fraction of nitrogen. Number of moles of nitrogen is equal to 0.1. So, 0.1 divided by 0.45. So, what you will get here? So this point, if you remove this one, this 4.5 by 4.5, which is equal to 1 atm. That's it, no? Yeah. Now, partial pressure of oxygen, which is equal to total pressure 4.5 into number of moles of nitrogen oxygen, which is 0.1 divided by 0.45, which is also equal to 1 atm. Now partial pressure of hydrogen is equal to 4.5 into, here it is 0.25. 0.25 divided by 0.45, which is equal to 25 divided by 45, means it will be 0.5. So 0.5 into 4.5. Okay, this is how you can calculate. If the weights are given, you have to find out the number of moles, mole fraction, and then partial pressures. So you have to remember the formulas. What is the partial pressure? Partial pressure is equal to total pressure into mole fraction. What is mole fraction? Number of moles of one particular component divided by total number of moles. What is the formula for the calculation of number of moles? So I will write all the formulas in one place so that it will be very clear. Pressure into mole fraction of this A. Mole fraction of that component. How to calculate mole fraction? Is equal to Na by Na plus Nb. If two components are there, Na plus Nb. How to calculate number of moles? Number of moles is equal to weight by molecular weight. If you remember this formula, you can solve anything. And also total pressure, as per Dalton's law, total pressure is equal to partial pressure of A plus partial pressure of B. Okay, clear? Thank you.